Good evening, everyone. Hope you had nice pizza and then some drinks to cheer you up. I'm Rajesh, staff engineer working for core architecture team at Ford, actually doing supporting Ford and Lincoln apps, as James mentioned, actually, which connects to the cars, and then we serve around 7.5 million users worldwide. It's a global app, and I also work on as a lead engineer on some specialist projects. And welcome. And today I'm excited to share with you our journey in building our app's DNA. I just put it there because it is catchy, but it still is relevant actually, because DNA is supposed to be the basic building block of our app. So that's why I put it there. It's a compose-based design system that we have built. Because our app is large, and then we have got two different apps. I'll tell you something about the context of it. We've got Ford and Lincoln apps together, which serves a lot of users across the world, and then we want our app to stand out. So we wanted to find something special so that to prove our brand identity and also make our developers' life easier. So we went for a design system. And don't worry, I will not be boring you with 45 minutes of my own talk. Actually, I've been joined by a few engineers from our feature teams, because they are the users of this particular design system library. So what they're going to do is they are going to share their experiences of how they used it and then how they achieved what they wanted to achieve. And then with that introduction, I'll go to agenda. This is the rough agenda. So first, let me go through the definition of what a system is, and then what our design system does, and then the components it has got, just as a basic principle, so that everybody is on page actually. And then we'll go with why did we go ahead with building a compose-based design system. Sorry.
I think we lost your audio. Can I
Audio is it?
So,
Okay, one second.
we lost your audio.
Audio. Okay, one second.
Maybe closer.
Can you hear me? Okay. Yeah. Oh, great. Thank you for that. Yeah, I was feeling that, but okay. Anyway, okay, you can hear me now. Hope you haven't lost much of context, right? So okay, and then we'll go into some. Now I need to talk a little bit lower, actually. So okay, now let's go into the deep dive into, not the deep dive, at least to a reasonable extent of how we modularized our architecture, and then how it helped our migration strategy, because we were moving from an older version of the app to a newer version of the app this year. And then we'll talk about the feature team's perspective, how they used it, and then what they think about it. And then I'm going to showcase a couple of components that are composable components at various complexity levels. One is medium complex, and then so that you will understand what it takes to build those ones. And then we use some tools for an automation for making our lives a little bit easier, and also to help developers and for their productivity as well as for their experience. And then finally, we'll end up with some future enhancements and visions that we are going to make. I think it switches off automatically after a while, probably. Okay. Anyway, with that, next, let's start with what a design system is. Let's talk about what a system is. A system is an interconnected set of elements that are coherently organized to achieve a purpose or function. I took it from Thinking in Systems by Donella Meadows. It's a very good book to read. It will change the perspective of how you see the world. And then with that, actually, you can see there are three words which are highlighted there. One is elements, other one is interconnection, and other one is purpose. Let's translate that into the design system library ideology. And what are those elements, interconnection and purpose? So if you take elements, actually you could see, yeah.
The battery thing that's dying.
Oh, is it? Okay. Okay. Yeah. Okay. Probably I need to keep on pressing it. Okay. Elements, you could say they are basic building blocks like composable functions or design tokens like colors and typography, and then also the themes, which are light and dark. which are the basic building blocks, and then they don't do much other than just being there until they interact with each other. And then this is where the interconnections play a part. Actually, what we do is like these basic building blocks, which are composable functions, they interact or they consume the design tokens, and then also they apply the themes. And these interconnections happen using the composables, the natural mechanism of having modifiers and also the state management, actually. So those help those interconnections to happen, so that the UI elements are presented the way in which we want the app to be presented, actually. And then let's see the purpose. The purpose is very, very clear. We wanted UI consistency across all the screens in our app. Our app is large, actually, probably it has around 50 to 70 screens roughly. And and then we had around 30 to 40 odd engineers working on it globally. And we wanted to make the development much more easier. And then we wanted the migration from 5.x to 6.x to be faster as well. So this helped because what we did is we designed and developed these composables which are well tested so that they can use it as it is. So, and also when we do it, actually we did it with accessibility and theming to be part of it as well. So it helped us to actually do a faster iteration in the delivery as well as the UI consistency. So I think that set a bar of our understanding on design system. So next, what we are going to talk about is why did we build it, actually, or why did we make a lot of effort to build it, actually. So it is basically Ford as it does it on its own. Ford as a company, we wanted to provide an immersive, consistent experience for our users, whether they are in the car with their dashboard on or when they are using the mobile phone. We wanted them to have a unique experience which stands out from other auto vendors. And also, in larger projects like this, we need consistency because you could have heard about some UI drift, which is like if it is a larger project and then too many people are working on it, you could see if there is a text box somewhere else in the application, then if you go navigate to some other screen in the app, it looks completely different because different teams develop on it. So we wanted to avoid that. We have been there because previous versions of the app had this problem. So we wanted to avoid those UI drifts from happening. And then we wanted to give a predictable experience. And then we had time and budget for that. So we wanted to develop a library and then utilize it, actually. And then, as I told before, it definitely accelerated the development, actually, because we created reusable, composable components. For example, a text field is used n number of times in the app. So, and then it had a lot of product requirements. So we developed it once and then used it everywhere in the app, actually.
Yes.
Right, okay, yeah. And then next one is, it definitely helped in accelerating our development because we provide a fully tested, reusable, composed component. And then also, there is a tiny bit of friction which will usually happen between the design team and then the development team because the handovers normally, there will be a lot of questions when the design team hand over to the development teams because they don't know certain things and then they will go for some wild questions. So we kind of had a separate team to work on that, which means we could take care of all those questions and then all those requirements that developers need, and then also designers handoff happens automatically. And then also regarding the maintainability and scalability, we were able to do easier updates. That means since we hid all this complexity inside the library based on the design requirements, the UI logic code in the app is as simple as possible, so it was a lot easier to maintain, actually. And then there are a lot of built-in features which comes out of the box, which is like basic accessibility. I can talk about accessibility a tiny bit. We didn't do the entire set of all the accessibility requirements, which was listed in the Google site. But what we did is we pick and choose a few of them, which are like font scaling and sizing, and then touch targets, and then color contrast, which are really basic, and then which helps our app to be inclusive. Actually, we did that. And then reducing dependencies. Okay, this is kind of a bit niche. Actually, if we have left it to the engineers to figure out what we need to build these Compose UI components in the app, probably we would have ended up with a lot of third-party libraries in our app source code. But since we had a dedicated team to work on this, we kind of restricted. We kind of restricted. Okay, yeah, we kind of restricted who is trying to connect to the monitor? Okay, hopefully nobody's trying to connect to the monitor. Right. Okay, anyway, reduce dependencies, so which means we have got a restricted list of dependencies that we need to add to the source code, and then which means less maintenance. And then an important note, all of these things are really nice to have and for an application of our size, but the trade-off is being we need to spend a significant amount of initial setup time, which a lot of effort went on to that across the design team as well as development team, and then ongoing maintenance is going on as well. We have a dedicated set of teams who are working on maintaining the product. Right, and then just want to set a context before I go into the architecture. Actually, so as I mentioned before, this is how our app looked. It wasn't bad actually, but I think the UI library that we also had an UI library before. UI library we had was like a single giant module or library that we shipped. But I think we weren't happy because of certain design decisions that we wanted to take wasn't included. So when we had time and effort or money for investing on a new version of the app, so what we thought is, okay, we should re-architect a tiny bit to make the migration easier as well as long-term maintenance easier. So this is how 5.x looked, and then that's how 6.x looked. It looks more or less the same. You could see that the buttons have moved a tiny bit, and then the certain information architecture has moved from this page to a different page. So a lot of things happen, but I think we didn't make much changes to the view model and other layers. But I think the UI layer changed a lot to make life of the users easier actually. So that's the context why we started thinking about writing a new design system. So move on here actually. Okay, jumps off. Okay, I just wanted to quickly run through before I go into the architecture. I wanted to just explain you just the general flow. We have got a separate repo, which is our design system repo, and then we use JFrog, which is Artifactory. That's where all the libraries are hosted, and then app repo pulls in all the dependencies actually from the JFrog. And then since we have versioned each and individual library, which comprises of this entire library, they can pull individual versions there actually, which are compatible. Just to explain you actually what this one does. Actually, you could see here we have got these were named as internal names. I don't want to confuse you with internal names, but I just for the sake of understanding, we have got that 5.0 library, which has got all these components, and then 6.0 library, which has got all the new components there. This is the new library. So previously there was a giant module which has got all of it, like core, components, and then theme all together bundled up as one single package. So when we started thinking about migrating to a new design system or new UI look and feel, what we did is we refactored our the existing library into 3 different unique library modules. One is core, another one is components, another one is FDS theme. And then what we made sure is like whatever is in the core and then the theme are common across these ones, so that we could control what is being shown, whether these components are shown or these components are shown, or what theme that we wanted to show it to the user. So once we have done this refactor, it made our life a lot easier because we could add any more different set of library components on here actually. So this architecture helped us a lot in the migration process especially. So let me go through certain things like what a core means, and then what a theme library comprises, and then what the component library comprises. So first let's think about core. It is actually a stable API. It is the public API which contains the basic elements that are used across our design system. If you could see the core library, it's a stable API. So what it does is it defines what, which means it has got all the interfaces and the generic utilities and annotations that is used by the feature module. This just has got the interface like color aliases, and then maybe token aliases, and then the implementation is provided by the actual component module. And then let's talk about theme. Theme is nothing but brings, this is a very simple wrapper module. What it does is it brings our design system to life, which means it takes the definitions from the core, like what is the color alias for the foreground, what is the color alias for the background, and then applies the implementation, which is like actual colors from the components, and then wraps it around the theme as well, which means this one controls all the styling updates. For example, all the styling, how the UI looks, how the component looks. That's what this one does. And then the component library is literally simple, but it took a lot of time because that's where all our compose components go. And like, for example, action button, app buttons, app text fields, and anything at all, cards and everything. All the things go there, and then all the color implementations for the aliases which are mentioned here go here. And then also the typographies actually. You could see 6.0 and 5.0 will have different implementations of colors as well as typography. So that's how the entire setup works. So this was really powerful because I think we could add one more set of library which can, and then this, if you modify this, and you could make the app to behave completely different. So key benefits, key benefits. Since it is modularized into three different units, we can ship fewer units. For example, if you are updating only the colors or the color tokens, we could ship only this library, which means our app dependency needs to change only for this library. Since it is modular, you can use it in the app in a mix and match way. That's how we can choose between this and this as well, actually. And then it definitely improved build performance because they are individual libraries, and then they can be built on its own, and then which means app doesn't need to build it again because it's already built and shipped. And then definitely it helped in strategic migration, as I told you, because we had this separately and then this one separately, and then maybe if you want to go to 7.0 or 6.5 or whatever it is, we can always add additional library component, and then maybe we can tweak this theme to supply a new theme, picking up these different version of the library component. Hope that makes sense, yeah? Then with that, I think next, I think I can hand over to Jack. Save. There you go.
Good evening, everyone. I'm Jack, this is Christina, and this is Zen.
Yep, okay, hold it. Yep.
And we work on the feature teams here at Ford, on the Ford app. And we're going to quickly run you through how we actually use the new Ford design system that Rajesh has just been telling you all about. So the first thing we would always do is we would look at the Figma designs. We would then break down the screen that we need to develop into the different features that we know we would have to use. So for this screen specifically, we have the charge state, the charge session details, the state of energy slider, a global start-stop charge button, and then the energy entry points. From here, we're going to specifically focus on the global start-stop charge button. Clicking on the actual feature in Figma will give us information about the component. Specifically, we've got this so that it gives us the information about the component that we can find in the documentation. So for this specifically, we're going to be looking at a selection button. This will also give us other information such as the text we'd need to include, the icons, the typography, everything like that. And it's a great place for our designers to actually give us the information about how the different states of the button would need to interact, meaning that when we actually go to look at the documentation, we can make sure that the component acts in the way that the designers and our managers would all expect it to work. I'll now pass over to Christina.
So the next step would be to after finding the component you need, would be to check that it's available and that it behaves in the way that you would expect it to. So one way we would do that would be through the demo app that the platform team created. And this was essentially a fun little playground for us developers to see all the components available in the design library. And it's also a great way to show our project managers and the product team that the component is looking and working as expected. So this was great because all the components were adjustable within this app. So let me just play the video. So on the right, we have a screenshot of what the documentation would be like for each component. And let me just play the video. So for the example from the previous slide, a selection button, we would go into the app. We can see a short summary at the top, and below all the different variations that the component can come in. So everything's in one place, very easy to navigate, which, great. And an example of a more complex component that we had from the previous screen was the state of energy slider. So again, all the components are nicely grouped into each respective group. So here we have the state of energy charger, slider, which was specific to the energy features in our app. And the reason why this component is a bit more complex is because, as you can see, there's multiple elements. And all these elements need to be updated as the state is updated by the charging level that the car battery is giving back to us. The other way to view a documentation for each component would be through the design system website. And one way of doing this was manually going through the side panel on the left here. Again, going through all the groups and finding each one. Or the nice and easy way to do it would be through the search button right at the top right-hand corner. And especially because the transition from 5.x to 6.x, the naming convention stayed the same. So if a button selection was called that in 5.x, it was pretty much most of the time also called that in 6.x. So you could very easily find components if they also were getting carried over from the old design system. So when you go on to the component that you need, at the top here, you can see the composable function written in Kotlin, and it just displays all the parameters that you would need for that function, what type you need to pass through them, whether it's nullable, and any default values that it passes through. And then just below that, we have a screenshot from the design library of, again, the different types of variations of the component and how you can adjust each one. As you scroll down, you are then presented with a few examples of code implementation. And this was really handy for us developers to refer back to if we were stuck or didn't know how to implement the component, especially as many of our components required states. So for example, if we didn't know how to implement the loading state, this is what we would refer back to, and it was very handy for us to have. And then just underneath that, again, we have a list of parameters, but a more detailed explanation. And this basically gives context to what the component would use, how the component would use each parameter. So yeah. Passing on to Zen.
So once we found the right component, what we do is very simple. We just put it into the app, and we'd set up the parameters that it looks for. For instance, over here you can see there's a non-click parameter, which we would call whatever button the component had. There's a text field, modifiers, the loading state, whether the button is selected, and finally there's a couple of modifiers for the button size. And all we do is put that in, and there we have it. We can see on the right the stop charging button can be good to go. However, before that, what we can actually do is see it in Android Studio. And how we do that is by setting up previews in our layouts. So over here, like before, we set it up except with a couple more additions, such as the theming. And we make some false data with the states and the loading states, and we plug it in, and there we have it on the right. We can see various states. That's also because of the FDS preview annotation that they've kindly provided for us as well. And yeah, this enables us to see the button in various themes, such as light and dark theme, as well as when the text has been scaled so that when the user modify it on their Android devices, we can see what it looks like for them as well.
Back to Rajesh.
Yep.
Yeah, great. Yeah, thank you. Yes. So you could see, I think, on the previous slide, I think this annotation, the FDS preview, and then setting up the theme. This is from the theme library, and then this is from the core library. So we provided them. I think it does an exhaustive list of left to right, right to left, a dark theme, light theme, and then various font size and scales. Everything is set for them, actually. They just need to annotate that, and then it sets everything for them. Okay, as I promised, actually, I wanted to go through a couple of composables that we have built of various complexities, and let's go to the input field. How can an input field be a medium complexity level? That's because I think our product design team needed a little bit of more functionality than what the native input field gives us. Like for example, you could see here it has got a leading icon, and then it has got a leading icon with some prefixes for entering phone numbers, and then it can this single line and multi-line as well here, and then there are some states actually. So they gave an exhaustive list of the requirements. So the problem that we are trying to solve here is like we don't want to give it all to all the engineers taking the input field on their hand and then just coding it, which would result in a lot of errors. It's error prone because there'll be various implementations, and then it will also be time consuming because they may need to go through the learning curve again and then to find out how to customize it, and then they have to apply the theme for it as well. So what we came up with is a single solution, single component which wraps the input field of material 3, but it does some intelligent things that the designers wanted actually. So some of the key features, some are out of the box that we normally give for all the design system components, which are like full design system theming, which is colors, typography, and spacing, and then built-in accessibility and testability hooks or test tags and stuff. They are all guaranteed actually, but on top of it, what we did is like, for example, there are comprehensive error states for a comprehensive state management, which is like you could see the error state being handled here, and then read only, and then on focus, disable state, enable state. All the states are handled. So it's all just passing parameters and playing with them. That's all the UI team, the feature teams need to do. And then also, single line, multi-line, I already mentioned about it. So that's about the input field. That's medium sized, and it probably around 300, 400 lines of code that we had. But I think those changes that we have in the input field need not be actually written 100 times, or because this is a very popular one. because it's been everywhere in our app for just capture, because it's a data entry powerhouse for us actually. So that saved a lot of hours for our engineers. And the next one is I want to take a simple thing actually, very low effort, but this one is used in multiple screens, like in the energy tab actually, what Jack was mentioning and then Zen was mentioning. It's a simple component. What we did is took a material tree, input time input, and then just overriding some default styling with some FDS tokens that we had, which are from the theming as well as from the core library. And then boom, then what we had is a component which developers can just drop on their UI layout, so that it just serves the purpose of automatically applying the colors and typography, and then light mode, dark mode, and then it is consistent across UI UX across the behavior of the app actually. So that's the simplest one that we did actually. And then there is much more complex one, which is a list item. I think Vita, if you remember, the list item is the complex one, which had lot of functionalities, because it had icons, it had delete functionality, and a number of other things actually. So that's a lot of lines of code. But so I wanted to go through a medium level and the simple level component that we use in our code base. That's that. And next is like I wanted to go through some of the tools that we used to make our life easier, and also to improve the developer experience. And KDoc is one of them. Let me explain what KDoc is. I think people would have used it. KDoc is nothing but like a Java doc. We can write Kotlin standard documentation format code alongside the code. So that why did we do that? Because documentation lives along with the code, and then it always encourages developers who update the component to keep it up to date. And then it improved definitely the developers' productivity, because in the IDE, as you see, if you hover over it, it just gives you what the component does, and then a code snippet of what they can do. And there are a lot of other features that we did. And then also it helps consistency. By consistency, what I mean is, like, I think we had a couple of engineers, or maybe at least at the peak, we had around 4 engineers working on design system. So they worked on various components. So at least we kept it consistent, the format and documentation format, as well as what we deliver to the developers. We kept it consistent, so that the users of the library find it standardized, right? And also maintainability. It definitely helped the maintainability, because anyone who is new to the team, who is getting onboarded, if they read the documentation, it makes it much more clearer. And also I want to show you one thing, right? Okay, if I play that, actually, you could see, if you highlight that, and then you could see it displays actual documentation along with the code snippets. You could see that. And then also on top of it, if it is a deprecated component, what you could see there is a summary of what it should be replaced with this one. And then the trick is, like, if you click on that, it automatically replaces the deprecated component in the code with what we have actually. What is the new component that they are supposed to use, which made the developers' life much more easier. That's that. And then what else? Okay, how do we do that? Actually, it's fairly simple. You need to do a multi-line comment, and then add some tags like params. I think up to there, actually, you can use GitHub Copilot to do that for you. But certain tags like sins, we used it for versioning. And then also it supports HTML and markup language, markup code on there. So what we leveraged it for is to make use of attaching screenshots that you saw in the previous screen. And then also to write some code snippets, actually, which you saw here. Here actually. All these things come from the KDoc actually. But how did we do that? Actually, we had we had something called Docker. Probably people would have used it. If you have not used it, there's a good tool that we could use. If you write a KDoc style documentation on the above the functions, and that's Docker is a plugin which you could include in your build.gradle in the library modules, and then you can run the Docker, and then it provides a browsable HTML file which you could host in GitHub Actions. That's what we did actually. We hosted it in GitHub Pages, so people can look into it as long as they have got access. So this was popular among developers, engineers, and then also product managers, so that they can have a look before they wanted to actually go for a sprint or something, planning or something like that. So that was popular. And then next one is Kotlin Poet. This is, I'm going to be quick actually, I think I know. Next one is Kotlin Poet. This is a tool. Let me tell what a Kotlin Poet is. It's a Kotlin API for programmatically generating .kt files. That saved a lot of hours of design. Our team, which is the core architecture team for this design library. It was a perfect use case for us to use because we had a single source of truth for all our design tokens, like color tokens as well as dimensions, which was hosted in Figma. So we used Figma API to pull the Figma JSON. And then we used to run this. We wrote an utility called importer. What it does is it reads the JSON file, and then using Kotlin Poet, it generates structured Kotlin code, which is compile time checked, and then we could generate these files. What it basically does is it generates val properties in a Kotlin file format, so that we could use them directly in our code base. So once we run that, there are some manual steps we need. We are currently pulling it from Figma, and then once the JSON is there, we are splitting the JSON into color tokens and dimensions, and then when we run this importer, it just creates files, and then we raise a PR against the repo. That's what we are doing, but we are thinking about streamlined integration, full integration. But this saved a lot of time, and also when you actually do it by hand, it is a monotonous job of copying the tokens which have changed, and there were typos, and then there were like copy paste errors and all the stuff. But this gives us a consistency of whatever is in the Figma, it just reflects back next day. So that's Kotlin Poet. And then there are a lot of other tools that we used, and these are very popular tools. Probably most of us would have used it, but I just want to breeze through it so that you understand how the structure works. We use JFrog which is artifact management. All these design libraries are pushed there so that app can use it. And then we used lint. We used lint not only to maintain our code standards, but also during our migration process. We run lint checks against to find out whether people still use the old library or new library, so that it provides the lint errors, which means we keep them informed that okay, they need to migrate this particular layout file or something like that. So we use that heavily there. Figma, single source of truth for UI UX. That's where all our designers work, and then hand off our designs to us actually. GitHub Actions and Bitrise. GitHub Actions, all the libraries that we build using GitHub Actions, which uploads it to JFrog using the pipeline. And then Bitrise, you saw the demo app that Jack and then Zen and then Christina mentioned. This demo app, whenever there is a change made and then the commit is done, it automatically runs a build, and then it uploads it so that developers can use it immediately. That's regarding the tools. Other tools that we used. Just to go through the pros and cons, I think already we know about it. First one is this was a huge win for us because this migration was done in less than 3 to 4 months actually, because we were planning to do, I think when the initial estimate was like 9 months-ish actually. That's what everybody mentioned. And then we made sure that, okay, everything is much more easier. And then we build all the components for you. and then you just need to test the UI layer and then make the UI changes, and everything should work. So it was a major win, and then we were able to achieve it. I think we started somewhere late May or something. No, May, June-ish actually, and then we finished. 6.0 is already live in production. So it was a major win for us actually. Yeah.
Thank you. Yeah, and it led to consistent high quality UI. I mean, from our perspective, it felt very, very easy to use, and it just made the app feel like there was one unified theme. I remember last year there was, before we migrated over, we had issues where I'd see multiple implementations of a button, and it made bug fixing that much more difficult. So yeah, the app definitely feels and looks and is more cohesive. And also this allowed us to focus more on the logic that we output, and in that sense, it led to a more consistent behavior as well. Yeah.
Okay, and then I think it definitely reduced the cognitive load of the engineers, because they just need to focus on the UI just building up. And then ease of adoption, since we worked really hard to make the API intuitive, which means easy to onboard the engineers. They can be productive on the day one by going through the documentation on their own, because it is documented, and then they can do the self-help. And then which we saw using KDoc, and then the demo app, and then also help them to understand how to use it, because the demo app source was also shared, which means they know how to actually show the preview and then use the component, and all the code samples were there actually. So let's go through the cons as well. I think there are a few things which is like communication overhead, because since we had an isolated team which was working on the design system components, we might need to interact with the design engineers, and who are like, there are two types of design engineers, one who develop the DNA, which is like the buttons, text fields, and text areas. And they are like our DNA design team. And there was one more set of team which is like who are designing the feature screens, like these screen types actually, which means we have to interact with them. That's just basically to actually get an alignment and then set the expectations right, to make our lives easier actually. Yep.
Yep. And I think one of the main challenges that we face as developers is that when there was a disparity between the designs and the components that we received, what would happen is that we'd go back to these guys, and of course they'd fix it very, very quickly. However, what we'd often have to wait for is when they update the library version in the main app that we develop on. So that often meant that our tickets would be stuck and blocked for pretty much the entire sprint. And often our PMs aren't very happy with us because of that. And it left us feeling very helpless in terms of what we can actually do. So, but I think as we went on with the migration, it definitely felt it sped things up.
I think that's why I think there is a potential for rigidity stuff is there, because this is a blessing. This is a blessing as well as a curse, because we focused more on the consistency part of it. The design system is really, really rigid, which means it offers very less freedom for the actual feature engineers to work on it. If they request, as Zen mentioned, actually, if they receive any request saying that, okay, can you tweak this component a tiny bit, they have to reach to us to get that sorted out. Or they could raise a PR on our repo, but I think they might need to understand how it works and all the stuff, actually. So there was a bit of rigidity on that, actually. So anything more to add? Yeah. Okay, yeah. Those are the learnings that we had. And then next one, I just wanted to go through some next steps that we had. The last point clearly proved that, okay, we need to improve something on the rigidity part of it. So what we are trying to do now is, like, our composables, you can add some content to our composables, and then the theming and styling and other things are taken care of. But even the content that we can add is all either list of data or states or whatever it is. That's what you can pass. It's very rigid. So what we are trying to do now is like, can we actually allow the people to pass content, which is a composed content, into it, and then make sure that, okay, it behaves the same way that it behaves everywhere in the app. So we are trying to work on that, but there should be a balance between them, because if we allow too much, then I think the consistency goes off. So we are experimenting that. And the next thing what we wanted to work on is a deeper connection between design files and which is a deeper API integration. Right now the steps are manual, like we download the JSON files and then we work on it even though it is automated in generation of tokens as KT files. The entire process involves a couple of manual interventions. So we wanted to make it seamless. Like when you click on GitHub Actions, it does everything for us. That's what we are working on. I think Voita is working on that in this sprint. And then since we have probably around 70 odd components in now, we are planning on getting screenshot testing done, which allows us to reduce the visual regression and also any kind of errors that come out during the builds. Actually, that's what we are trying. Probably we should have done it a long time before, I think, but I think the project of migration was really, really tight on deadlines. So we were focusing on making sure that our future teams are not blocked and then getting that done. So that's that. And the next thing is on bill of materials. So bill of materials implementation. Okay, as I told you before, our design system library has got 3 distinct libraries having different versions. In some cases, we manage them because we know what is compatible versions across these libraries, because we have got a POM file which says, okay, which version of a core library is compatible with which version of the component library. But now, having said that, I think it is harder to manage even for us sometimes. So we are going to introduce bill of material implementation, which means the feature teams can manage that, because it will give them all the compatible versions of all the libraries that they could use without any problems. So that's the next steps that we were thinking about. And with that, I thank you very much for listening. Yeah, any questions at all?